Hello guys, so in this video we would be learning about hashing as well as the internal working of your hash map. As I told you that the set as well as this hash map data structure provided in the collection framework generates your O of 1, that means a constant time complexity. Okay, so we would be seeing how this process works. Okay, so let's start with our video. So the first important question arises that what is hashing? So hashing is the process of converting a given key into another value. Okay, a hash function is used to generate the new value according to a mathematical algorithm that has been passed to it. Okay, so there is a kind of an algorithm that generates a particular value for a particular key. That value is known as a hash. Okay, simple as that. Now we would be understanding that a good hash function uses one-way hashing algorithm. Okay, what does one-way hashing algorithm means? One-way hashing algorithm means that you cannot get your that your hash cannot be converted back into your original key. Okay, so now what is hashing? So in Java, as I told you, that sets use over one time complexity. So how does that occur? So basically in Java, it is the process of converting an object into an integer form by using the method of hash code. Okay, it is necessary to write a hash code method properly for better performance. Okay, so for this video, you just understand that there is a method that is the name of a hash code that generates a particular hash for your any value. That might be a string value, integer value. That see here also I have written that, as we know that hash map uses internally hashing, but map contains might contain the key as a string. So what to do now if there is a string key? Okay, we said that hashing is done for an integer object into it converts an object into integer, but what if the value passed is a string? So let us check it out. See how to convert this string key into integer form. So let us assume that there is a key. Okay, any key for that instance. I hope you understand the map concept na, that there is a map. In this there is a key, for example, that might be any alphabet, and associated with that is a particular digit. So this is a particular entry in your map. Okay, so now we would be passing this key would be passed here into our hash function, and it would return an integer number. Okay, what would it return? It would return an integer number. Say that number might be 2544. Okay, because our key is not restricted to just one character or an alphabet. It might be any alphabet, name, city, name of place, person, something, anything it might be. Okay, so now we pass this hash into this hash function, and we got this value. Now we would be using the modulus operator, and we would mod this value with this value. For example, if our hash capacity, um, for example, if we are having a size of 5, list of size 5 elements, and we got a hash function that is 2544, so we would mod this with 5. So what we would get remainder as 1, not 1, it would be 4, because at this point it is 4. So we would be getting index of 4th. So at 4th position we would be putting this value. Okay, now let us for an instance assume that there are some values, and this is your list. Okay, so these are your certain values, that is god, dog, pen and a tap, and these are some values that are to be stored. This is basically a map and a key value pair, and we have to store it in a hash map. And internally basically hash map uses hashing and hash tables. I would be telling you how this hash map internally uses this st- structure. So basically what it does is I have generated some hash for this all these values. So how have I done that? See, I have written a simple program for this case, that is get hash. Okay, so what my get hash function does, it takes the first value and adds it to your sum, means sky value of g, after that o and d, same as god, dog, pen and tab. So now my two values are same. Okay, so this dog and god have the same characters in that. So I have made this random algorithm. Okay, in java, the hashing, the proper technique uses a different algorithm, but I have used a pretty simple algorithm here. So in this it is calculating the sky values of all the characters and giving me the generated hash. But yeah, two values are corresponding to the same point, that is 218. So that situation is called a collision. Okay, we have to understand that two keys can generate the same hash. Okay, this is called collision. Yeah, that might be true, because key 1 and key 2 might generate the same function. So what to do in that case? Okay, see, now what have we done? So let us put the values into this hash map. So it is, the total size is 5, 0 to 4, 5 elements. And first of all, God came, and then it generated our hash of 218. So what I have told you, that 218 mod 5 would be 3. See, modulus is a pretty simple operator. So because how did we got mod? We divided this. See, we did 218 by 5 and we calculated the remainder. See, for first time it got 20, then it got 18, then got 5 3s are 15, and then we got our remainder as 3. So it returned us the remainder. Okay, so we got 3 as the remainder. So at position 3 we would be storing this god. So in this, all these you consider them as buckets. So at this point, how to store this key and value? See, in simple array we can only store values or keys of certain kind, but here we are using this uh, map interface, so we need to store key and value. So what is the phenomena, that there exists a linked list of all these nodes. So this is not just a node of integer, this is a node, this is a linked list node. Okay, and other nodes associated with that. So it would be having, see, this would be a node, it would be having your uh, string part, it would be having your string part, it would be having your integer part, and it would be having your node to your next pointer. Okay, so at this position, oops, uh, where were we? Yeah, so at this position, um, so here came our god with the value 22. After that dog came, so dog also took the same value. So after that there would be a link. See, understand this to be a node, and after that this is the next pointer of this node, and it would be pointing to another node. So here would be dog, contents of dog, and the next pointer would be null. And so then it would come 227, that is pen. So pen came, so it would be storing here the list in the form of this node only, that first the name, that is pen, then the value associated with that pen, and the next pointer, that is null for now, and then 229. So at that last point, tap would be stored. Okay, If you haven't understood this, you might picturize well with this diagram. See, I told you that all these things are the buckets. Understand it first this way, then we would be understanding this way. So this is your index. These are your indexes. Okay. At every index, see in your hash map, the first index is null. We can store null key value pair. And at the first index, that there is a key, there is a value, and there is a next pointer. See, at the time of collision, what we did is we created a linked list. That is, if we want to traverse from this, if we want our value to be 10, so we have to traverse in the first index, because our hash code gave the value. So, and in that we would be traversing the first key, then we would be going to the second key, and after that to the third key. So yeah, we can say that this, in these cases, if we had n lists, so this time complexity is not of O of 1. But yeah, it is more efficient than your other data structures. Okay. But in other cases, if see, these are having null values, so we can say that it is an approximation to O of 1 time complexity. Yeah, pretty well understood. If you don't understand this way, you might like this way. See, in this way, it is your array indexes called as buckets. So at this, see, this is the hash code generated, and this is the key, this is the value, and this is the next pointer. So in this way, there is an array as well as linked list representation to store these complex data structures. Okay, we talked about collisions, and now we would be talking about applications. So hashing is the most commonly used to implement hash tables, hash maps. So basically hash table and hash map is the same, because hash table also stores key values pairs, and we can access using that index also. But yeah, the difference between, there are various differences between hash tables and hash maps. So as hash table is synchronized, whereas a hash map is not synchronized, and hash table does not allow your first key to be null as we did in this case. So that is another difference, and there are certain more differences you could check out on the net. So I hope you understood the main important logic of your internal working of your hash maps sets, because the underlying principle is hashing, and this data structure consisting of their arrays as well as linked list representation. So I hope you all like this video. This is a very important video as far as your placements point of view.